I think we can now move on to the last presentation. Linda Silva will present us the Azores Infrasound Network. Linda, the floor is yours.
Good afternoon, everyone. So, my name is Linda, and my talk is about statistical analysis and characterization of the main detection on the Azores Infrasound Network. I will start by an introduction of the Azores Infrasound Network, and then I will present some event analysis based on the multi-channel correlation for a near data. And moreover, I will present the RMS analysis. So, the Azores is located on the Atlantic North. It is comprised 9 volcanic islands divided into 3 groups. With focus on the central group, we have with focus on the central group, we have the IMS IS-42 station with 8 absolute pressure sensors. In 2022, during a seismovolcanic crisis installed in São Jorge Island, we deployed a portable array with 4 differential sensors in collaboration with the University of Florence. Last year, also due to a seismovolcanic crisis in Terceira Island, that started in that island, we deployed another portable array, this with 6 differential pressures. To complement our network, we have plans to expand the infrasound network to Fayal Island and Santa Maria, and for more information about that, you can see the e-poster on section 3.1. So, for the main feature, IS-42 has a main array shaped as a pentagon with a triangular aperture subarray and a maximum aperture of 2 kilometers. SG1 has a central triangular design with a maximum aperture of 130 meters, and the sensors are 400 millivolts sensitivity. The third array has a diamond shape with 2 centered sensors and a maximum aperture of 140 meters. In Terceira Island, we have 5 sensors with 800 millivolts sensibility, Pascal sensibility, and 1 with 100. So we use the multi-channel correlation analysis in the time domain, and we apply the window left of 10 seconds with a shift of 1 second, and also a bandpass filter of 1 to 10 hertz. This was in order to obtain detections characterized in terms of amplitude, back azimuth, apparent velocity, residuals, and frequency. Here we can see long-term observation of data from IS-42 between June last year and July this year, displayed on DIVA software. We can see the seasonal variations, namely in the dominating frequencies like the microparents and the surf frequencies. And we can also see the behavior that in summertime the detections are mostly between 0 and 180 degrees, and during the winter time is between 200 and 350 degrees. The data here was used to compare with the seasonal variabilities that we have in our portable arrays. So here we have the portable arrays, the detections. In the first plot we can see the pressure, in the second the back azimuth, and then the velocity. We can see that we have a lot of background noise, but besides that we can see that during the winters we have a lot of detections that are associated with storms And also with the seismo activity, in December we had an increase in both islands. And you can see all the recurrent noise backgrounds and the same trends that we saw before. Here we have a storm that passed in October 2024 in the Azores, later related with Kirk storm. We can see it arriving firstly at Ch2 and a few hours later to Terceira array with less ref. And this storm was detected in terms of high frequency and high amplitude. As I said before, we also have two ongoing seismovolcanic crises occurring in the Azores, and relating the earthquakes that we have, were recorded more than 1,007 earthquakes that fulfill our detections threshold. Namely the distance of a maximum distance to the array of 20 kilometers, a depth of 10 kilometers, and a magnitude above 1 local magnitude. So after we choose the selected earthquakes, we plotted the earthquakes and now all of our detection in Terceira Island. We also did the threshold of the detections by applying a time delay and azimuth deviation of 10 degrees. In the second image, you can see the plot of all the earthquakes, and the blue dots that are not that visible but correspond to the detections in our station that could be correlated with the earthquake. So our results show that 40 events were detected and are associated with shallow earthquakes with magnitude larger than 1.5 and distance less than 12 kilometers from the array. You can see in the first images the detected ones are the ones with a red circle. We applied the same method to São Jorge Island, and from the 122 events selected, 16 were detected, and the results are the same. We had shallow earthquakes with magnitude larger than 1.5 and distance less than 12 kilometers. Additionally, and to understand the variability of our portable arrays during the seasons, we applied the RMS for each one of them. And we can see in the first plot that for the Ch2 we have a more constant RMS value that is increasing in the winter times. In Terceira Island we have a lot more variation, namely during the daytime. If we correlate the two of them, we can see some pikes, namely in the 10 a.m. and 3 p.m. in autumn on Terceira Island. In summer, we have more or less the same pattern in the both arrays, despite the last pike at 9 a.m. p.m. In spring, we have you can see you have a lot more pikes in Terceira Island, and in winter we have the same values but with a lot more variance. So we went to see the back azimuth of each pike in Terceira Island, and the detections are consistent to the west, and we have a query in operation during the daytime in the same back azimuth. So, in conclusion, for a one-year detection, we saw the expected seasonal variation in all the arrays. Regarding the storms produced high energy detected in the arrays in terms of high amplitude, more than 0.5 Pascal, and high frequency, more than 2 Hertz. The earthquakes detections in the arrays depends on the hypocentral shallowness, the magnitude, and the distance to the array. and also the noise level at the array. We saw, and this is also a conclusion, that the third array is affected by local source of energy during daytime, namely the query that we saw that is at less than 2 kilometers from the array. São Jorge is free of those occurrences.
Thank you very much, Linda. Any questions from the audience? So you presented results for earthquakes which were local earthquakes, right? So
For local work, yeah.
do you also have maybe mining events on the islands, or some mining explosions, mining events?
Yes, we have, and this was just a few events that we detect, but we also have mines. We detect airplanes and bolides.
Okay.
Also, we have other.
And for the mining events, is the threshold lower than for earthquakes, or is it comparable?
We have to study that.
Okay, thank you. Any other questions?
Yeah, for the earthquakes, were you able to determine Beckhardsmut and slowness? So I was just wondering if you see on the infrasound network the seismic wave, or you see an air pressure wave.
Okay, you are asking if my detection is about, it's related with the seismic wave or the...
Exactly,
wave?
yeah.
Yeah, so this is a preliminary study, and we already had an acoustic wave. So this is selecting the ones that can have the acoustic wave to further ongoing work. So.
Okay.
Yeah, my question is about PMCC processing for your other stations, the ones that are like with small aperture. Did you use the same PMCC processing than for I-42, or basically it's like what are the limits of the PMCC processing for the smaller stations compared to I-42?
Our stations compare, so IS-42 also use the PMCC.
Mm-hmm.
Sorry.
So let me clarify it. It's,
Yeah,
what kind of processing did you use for the smaller stations in terms of, for example, the frequencies that you selected or the frequency ranges that you use for obtaining the detections? Is there any difference with the I-42 processing, or is basically a shared configuration processing for all of those?
yeah, it's basically that, yeah.
It's the same?
Yeah.
Okay, okay, cool.
Thank you for your questions. Let's thank the presenter once again. And,